let's start our discussion about differential equations with linear differential equations. So how can you tell if an equation is linear or not? Well, if it's linear, then it can be written in this form. Box times y prime plus box times y equals box, where box can be any function in terms of t or x or whatever your independent variable is. But the point is it can't be in terms of y. That's the only restriction. So your equation can only have y in it in the linear form. So it's got to be just y. It can be, attached to some constant, but that constant cannot be in terms of y. It can be in terms of x. So this could be sine x times y, or x to the fifth, or e to the x times y, or this could be e to the 5x times y prime, or this could be any, but they cannot have y's in them. It's that easy. So let's, it's actually worth noting the fact that sometimes you're going to see it in this form, the standard form. And the reason you're going to see it in this form is because this facilitates a process called finding an integrating factor, which you're going to see in probably the next video. But so sometimes teachers are going to ask you to not write it in this way, and actually anytime you're going to write a linear differential equation to write it in this way. It really depends on your teacher. But know that they both exist. That's a standard form, and this is a form that you may see at times. So let's do a couple examples. Over here we have y prime plus 2xy equals sine x. We don't want to solve it. All we want to know is it linear or not? Well, okay, we have our y prime. Good. And then we have some function times y. Okay, that function doesn't contain y, and y is linear. That's good. Equals some function that doesn't contain y. It's linear. Perfect. We don't have to do any work. You can just tell by inspection. Sometimes, though, it's not that easy. This one, we can't tell. There's a lot. I mean, there's a y to the third. There's a y squared. There's a 1 over y. It looks a little iffy, but we can't know. Our first inspection should tell us that, no, that shouldn't be linear. But we got to do some work to be able to make sure that it's not. So let's go ahead and get rid of these denominators. I'm going to go ahead and multiply by 3y to the third. I'm going to multiply both sides. So I'm going to get y prime is equal to 3y to the third. And then this guy, 1 over y plus 4 all over 5y squared. Now this guy goes with him. Now I got a 3y over 5. And then this guy. So I'm going to go ahead and multiply everything out and write it again. So I'm going to have a 3/5 y over y, or just 3/5. Then I'm going to have 3y over 5 times 4, or 12/5 y. Then I'm going to bring this to the other side. So I'm going to have y prime minus 12/5 y is equal to 3/5. And that obviously is linear because we got our y prime, and y only occurs linearly in the equation. So you can't always tell just by looking at it whether it's linear or not. If you can see that it's linear, it's linear. But if you suspect, if it looks like it's not, you got to be able to make sure. But sometimes, like in this example, no matter what you do, no matter how you manipulate it, you can't get it to be linear. And the reason, the way you can know that is here we have y to the third occurring by itself. No other y's to cancel it out with. So we have a y to the third, no way to get rid of it. It's not linear. Here we had a y to the third and we had a y squared, but we also had this, and these guys were on different sides and they helped cancel each other. Him, he's by himself. So when you have a lone factor of y that isn't happening, it's not linear, so it's y squared or y to the third. If it's sine of y, you probably don't have a linear equation. But go ahead and explore all possible options if you're asked the question, is this equation linear or not? So there you have it. That's linear equations. More to come on why we care about them.